Hello everyone, welcome to Circles Part 1. In this session, we will learn few theorems. So first, let us start with Theorem 1. What does Theorem 1 states? It states that equal chords subtend equal angles at the center. So this is a theorem statement. It states that equal chords of a circle subtend equal angles at the center. So for this, let us take a circle. We will take a circle and label it according to the question, and then we will proceed. So this is our circle. Yeah, now we will take a center for this. Let us name center as O and equal chords as A, B and C, D. And if these chords subtend angles at the center, let us name this as angle 1 and angle 2. So we have to prove that angle 1 and angle 2 are equal. So for this, let us first write what is given. Given AB is equal to CD. And what is our RTP that is required to prove? We have to prove that angle AOB is equal to angle DOC. For this, let us compare two triangles. What are the two triangles? Triangle AOB and triangle DOC. When we compare these two triangles, we know that AO is equal to OD since it forms the radius of the circle, and OB is equal to OC. It also forms the radius. And what is given? It's given that AB equals to CD. So these three are nothing but they form the sides of the triangles. Therefore, we say that triangle AOB is congruent to triangle DOC. Now we can compare their congruent parts. That is, according to CPCT, we can say that angle AOB is equal to angle DOC. So that is our required statement in the theorem. So we have proved that equal chords of a circle subtend equal angles at the center. Now let us go to the next theorem. Now let us take theorem 2. First let us write the statement. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So this is a statement of theorem 2. Now let us proceed for the proof. So we have a circle here. According to the question, we will label the circle. So let us take this as a center. Again, we will take the similar kind of labeling for the circle AB as we have done in the theorem 1, CD. And the angle subtended at the center is, let us name this as angle 1 and this is angle 2. Yeah, now if the angle subtended by the chords of a circle at the center are equal, that means when we compare to the theorem 1 and theorem 2, here what is given is angle AOB is equal to angle DOC. This is already given. Now, what is our RT? What we have to prove? We have to prove that AB is equal to CD. Now, to proceed for the proof, we will compare the two triangles. What are the two triangles formed in this figure? Triangle AOB and triangle DOC. Now, when we compare these two triangles, we know that OA is equal to OD, which forms the radius. And similarly, OB is equal to OC. This also forms the radius of the circle. And it is already given that AOB is equal to angle DOC. This is given. So now we proved that triangle AOB is congruent to triangle COD. Now since these two triangles, but by which rule? SAS congruency rule. Therefore, according to the CPCT, if we compare the congruent parts, we get that AB equals to CD. Hence, we have proved that if the angles subtended by the chords of a circle at the center are equal, then the chords are of equal length. So, this is what the theorem 2 states. Now, let us go to the next theorem. Yeah, now theorem 3. So it states that the perpendicular from the center of a circle to a chord bisects the chord. So this is theorem 3 statement. So let us read the statement once again. The perpendicular from the center of a circle to a chord bisects the chord. So for this we have a circle. Let us label the circle according to the theorem statement. We take a center as O and we take a chord as AB, and he says that the perpendicular, if we draw from the center of the circle to a chord, bisects the chord. And for this we do a little construction. We will join AO and OB so that we get two triangles for comparison. So what is given? Given is a circle we have and AB is a chord. So what is given? We'll write AB is a chord and OX is perpendicular to AB. So this is what is given. And what we have to prove? We have to prove that AX is equal to BX. This is what we have to prove. So to proceed for the proof, we will compare the two triangles. What are the two triangles we have? OAX and O triangle OAX and OBX. So when we compare these two triangles, OA is equal to OB, which forms the radius, and OX is equal to OX, which is common side for both the triangles, and angle OXA is equal to angle OXB, which is 90 degrees. That is already given for us. So now these two triangles, triangle OAX is congruent to triangle OBX according to RHS congruency rule. Therefore, according to CPCT, we get AX equals to BX. Hence, we have proved that the perpendicular from the center of a circle to a chord bisects the chord. Now let us go to the next theorem. Yeah, Theorem 4 states. Theorem 4 states that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Perpendicular to the chord. So if you compare, it is similar to the previous theorem. Yeah, there it is already given that it bisects the chord. We will proceed with the theorem. For that, we will do a little construction in the circle. That is, it is similar here also. It's similar to the previous theorem, statement 3. So we'll take the same labeling. This is as X, and we did construction. That means we have just joined this. Now, what is given? In this theorem, it's given that AX is equal to BX. This is already given. So what is our RTQ? That is what we have to prove in this. We have to prove that OX is perpendicular to AB. Now, to proceed for the proof, let us compare these two triangles. That is triangle AOX and triangle BOX. Now, if we compare these two triangles, OA is equal to OB. This forms the radius. And OX is common for both the triangles. And we know that AX is equal to BX. This is already given. Right. Now, according to which congruency rule? SSS. Because we got these two, three parts of the triangle similar. That is sides. Therefore, it is congruent according to the SSS congruency rule. Therefore, we state that according to the CPCT, we can take AXO is equal to angle BXO. Therefore, we have proved. So, this is our theorem 4, which states that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Now, what is that we have to proceed? Now, we have to show that it is perpendicular. We have got it equal, but at the same time, we have to show that it is perpendicular. Now, for this, we will take the concept of straight line, straight angle. That is, when we take the angles on a straight line, that is a linear pair. When we add this, it should be equal to 180. And since both are equal, in this place, if I substitute angle AXO, which is equal to 180 plus 180, that means it becomes 2 times of 180, which is equal to 90. Therefore, we get that the angle formed is a right angle. And next, in the next session, we will continue with the remaining theorems. Thank you.